Welcome to the Cosmic Pie Podcast. I'm your host, Wayne Barkhouse.
And I'm Robert Moore.
This is season number 3, episode number 1, Robert.
Right. I can't believe it's been 3 years we've been doing this.
It has been. It would have been episode 1 a week ago, but what happened?
Oh, what happened? Well, we were locked out of our room here. Somebody engaged a mechanical lock to which we have no key, and so we weren't able to get in.
Tighter than Fort Knox.
Yep, at least for as far as we were concerned. Well, I don't know. We probably could have gotten in, but people would not have been happy with us.
I told Robert to go through the ceiling tiles, but he objected.
I'm not going to do that. I got a little too much padding to crawl through ceiling tiles.
We are broadcasting from the campus of the University of North Dakota here in Grand Forks, North Dakota.
Yep.
We're so warm out.
Well, it's something now. For those who don't know, it's 0 Fahrenheit out there.
The time to go from one building to another building on campus is greatly reduced this time of the year. Do you notice that?
I do notice that. The average time, anyway. I'm still one of the slowpokes because I can't breathe.
And we do have a live chat feature that's running, so you have any comments or questions you'd like to ask us during the podcast, feel free to use that option, and we'll be watching it closely.
Yep. Or watching it somehow.
Yeah. Now, this is the big week, in astronomy, Robert.
It is a big week.
This is Super Bowl week for astronomers. The big meeting of the American Astronomical Society is taking place right now, just outside of Washington, D.C. So there'll be a lot of things that'll be in the news over the next several days.
Right.
That will be interesting to talk about, and maybe we'll put some of those things together, those items, for Tuesday next week.
Sounds good to me.
Okay.
All right. I mean, I've got a couple of friends that are at the meeting, 3 friends that are at the meeting, so one of them's been a guest.
Oh, nice. So maybe we can ask them if they see anything interesting that we missed.
Yeah.
Kind of let us know.
All right.
So one of the things we want to do for the first item is to update some of the things we've talked about at the end of last year, and this involves the sun.
The sun.
So in particular, the Parker Solar Probe.
Yes.
So the Parker Solar Probe did make its closest approach to the sun. This was on Christmas Eve, so December the 24th. It came within 6.1 million kilometers. That's the closest any man-made object or human-made object has approached the sun. And it was traveling at a speed of 690,000 kilometers per hour.
Right. That's got a little oomph to it.
Man, if you travel that fast, it wouldn't take long to get to Europe, would it, from here?
Would not take long at all. And 6.1 million kilometers, I've got to ask, is that it getting inside the corona yet?
Oh, for sure.
Okay.
It's definitely inside the corona.
Okay. So it's inside the outer atmosphere of the sun for those.
Yeah, that corona, I mean, even during total eclipses, you can see those streamers stretch out huge angles on the sky.
Right.
And given how far away the sun is, I mean, you're talking millions and millions and millions of kilometers. So it's definitely got to be in the outer part of the sun's atmosphere, that corona. In fact, that is what it was designed to do.
That's what it was designed to do.
Yeah.
I didn't know if it was there yet, though.
Yes, to taste the outer atmosphere of the sun.
Right.
And to do that in the heat, of course, at very high temperature, you got to have a nice heat shield in the front, which is what you see in this sort of cartoon representation of the solar probe itself. And the little instruments kind of stick out the side a little bit.
Yeah.
I feel like it's almost like, you drive along in the car and you're sticking something out the car window, but not too much because you don't want it blowing out of your hand. You kind of stick it out on an angle a little bit, just enough to feel the impact of the rushing air going by.
Right.
It's that kind of gradual thing. Right?
And the thing to remember is the corona of the sun is rarefied space. It's not like, cirrus clouds in the upper atmosphere, the upper troposphere of Earth are denser than the sun's corona. So there's very few particles that it's actually hitting, but they're moving really fast.
Right, and so this begs the question of what is temperature. So temperature, at least one way of thinking about it, is just the average motion of things, the average kinetic energy.
Right.
So you're talking about the average motion of these particles, and from that perspective, temperatures are millions of Kelvin in the outer, very tenuous atmosphere of the sun.
But again, there's not that many particles there, so you're not getting hit often, but when you get hit, things are really packing a punch.
Now, of course, very exciting is to get some of the data back from the probe to see what it actually measured, and we don't have that yet. So the
Okay.
probe sent back signals saying that I survived. I'm still here. I didn't burn up. My instruments are still working. But the full data set hasn't been sent back yet. So they will do that over the next several weeks.
Yeah, you probably want that when you're a good bit away from the sun so that the signal isn't degraded by...
Yeah, and he has to turn the right way to make sure the antenna is pointing towards the Earth.
Right.
But you have to watch where the heat shield is pointed, of course, right?
Right.
So you have all those factors to worry about. So we'll get all that information back, and hopefully there's something in there that surprises everybody, because that's the cool thing about astronomy is the surprises. You just never know.
Right.
In fact, we know astronomy in general is what we call a gateway science.
Yeah, gateway science. And by that, we don't mean like what, anyway.
Yeah.
We mean it gets people interested. You see all these nice little pictures and concepts and everything. You go, that's neat. Wonder what that's from. And you start looking into it more. And that leads you into physics, which in turn can lead you into chemistry or geology or any number of other sciences.
And that brings up an interesting thing, too, is remember anything that Robert and I say is solely our own opinions. And not those of any other entity, including the university in which we're employed at.
Right.
Got to make sure we cover that.
We should make
We
sure.
do have that in the description, by the way.
Cool.
So, no one could say we never said that, because
Right.
it's written there anyways. But yeah, astronomy is neat in the fact that there's, use a pun, it's out of this world.
It's out of this world. I like it.
You never know what you see, right? So you design new spacecraft to do new observations, to go to a place we've never been before. You can predict what you might see, but what you actually see can be different.
Right.
And that's where the interest of science comes in.
And there's a lot of practical benefits for things like the Parker Space Probe, solar probe, in that the sun has real effects. If we can get a handle on when the sun's going to throw a temper tantrum and send out a flare or a coronal mass ejection, we can better protect our satellites and our electronics from the effects of when these things slam into Earth. So we want to know as much about the sun as we possibly can. And that's part of the reason behind sending this Parker solar probe.
And it makes, me think about a time in the past where people would often say, why should I study astronomy in space? It has absolutely no impact here on Earth. Well, impact is the key word.
Impact is the key word.
Because immediately you ask them, well, what happened to the dinosaurs, right? And you get into this rabbit hole of explaining maybe we should pay attention to what goes on beyond the Earth in the form of having a space program that could intercept an inbound comet or asteroid that could hopefully deviate its path so it doesn't have a direct collision with the Earth and therefore save you,
Right.
as the person who asked the question, right? And your
Asteroids.
family.
Asteroids, nature's way of saying, how's that space program coming?
But astronomy also is interesting from the point of view that you don't need to have, multi-million-dollar equipment to be able to see or study some effect. You just need your eyes in some
You need your
sense.
eyes.
And last night, for example, the moon, at least in most places of the Earth that could see the moon, occulted Mars. That is, went in front of Mars. And a pair of binoculars would show it really well. If you have a telescope, it's even better. You could watch the moon cover up Mars. So Mars go in behind the moon relative to the Earth and eventually come out the other side. So what do you need? Your own eyes? And to make things better, you have a $30 pair of binoculars or
Right.
whatever, right? You don't need, some advanced equipment that requires, a top-of-the-line sort of technology to look at.
With practice and training, there are even some variable stars that they ask for visual observations of it. How bright is it over time? So, there's actually a lot you can do with just your eyes. And go ahead.
Yeah, and so the other thing we talked about the sun, so the other interesting thing that's happening right now as we're talking, so those of you who are able to get outside
Right now.
about 10 minutes roughly after sunset, of course, don't hurt your eyes. If you can look towards the western sky, towards the sun, so just above the sun, you will see a comet.
Yes.
So this is Comet Atlas, C/2024 G3.
Which means it was discovered last year.
Yeah, that's the catalog name for it. And this image, what you see here, is actually data taken from the Soho spacecraft. And the position of the sun is actually made by that white circle you see in the very center. And then there's sort of a disk outside of that, or the circle is sort of near the center of the disk. And that's to block the very bright part of the sun, the photosphere, and some of the other part of the atmosphere just outside of that, the brighter part of the corona. And then what you see beyond that is sort of the material that gets ejected from the sun itself. So things like corona mass ejections, solar wind, and so on. And in fact, if you look carefully, especially let's say near the bottom, you see little dots of light. There's actually stars. Those are stars that lie in the direction of the sun right now.
Right.
And what you see at the top is that big white splash of light. That's the Comet Atlas. So this image was just taken, yesterday. So what you can see is very close to the sun. And if we looked at the image just before we came down to do this podcast.
And it's still in the view.
And it's still in the view. It's just off to the left side now of the field of view of the Soho spacecraft. So very soon, by tomorrow, it's going to be outside the field of view.
Right.
We're not going to be able to see the comet with that instrument. But you can see the comet very low in the west, close to the sun. Don't look at the sun with binoculars or telescope. It's not worth ruining your vision for the rest of your life.
It's definitely one, get a good clear horizon of the west and wait till the sun is down.
And the comet is supposed to be extremely bright because it is so close to the sun and it's reflecting a lot of light. And it's also getting closer to the Earth.
Right.
So in fact, it will get closest to the Earth today. And that distance is about an AU. It's about 140 million kilometers. So that's approximately 1 astronomical unit, which is the average distance from the Earth to the sun. But in terms of close approach to the sun itself, notice it got within about 14 million kilometers. So that is extremely close.
Right. They were worried that it was going to break up because of the effects of the sun, the heating and the gravitational tidal forces and all this sort of thing. They were really expecting it would probably break up.
And that's only a little more than double the distance that the Parker Solar Probe got to the sun.
Yeah.
And you imagine you need a nice strong heat shield, to dissipate that heat that the solar probe is taking. Imagine the comet, it's exposed directly to the sun's energy.
I'm surprised it didn't break up.
Yeah, I'm surprised too. In fact, we had lots of examples in the past where we see comets get near the sun and break up.
And these were some of the ones that you heard, this will be the comet of the century, and then nothing happened. Well, it's because it got close to the sun and broke up.
Yeah, so we'll see. Tomorrow's supposed to be a good night to look for the comet. It'll be a little bit further away from the sun and therefore a little bit easier to see. And of course, it depends on the weather. So you need clear skies towards the west. And of course, you want to have an unobstructed view if you can, no large buildings in the way and so on.
You mean like on campus?
Well, you need buildings, right? We're not all underground, right? But if you live in a mountainous area,
Yeah. Mountainous area probably
might
get
be
a
better.
good
You
view.
wait till it goes below the mountain, then you can look at it or something, right?
Right.
Yeah, so that can be an issue. Now, coming up this evening at around be 12:11 a.m. our time, 1:11 a.m. Eastern Standard Time, is a launch of a Falcon 9 rocket carrying 2 landers that are heading to the moon. So this is part of the new, if you like, introduction to exploration by humans eventually of the moon itself. So this is paving the way once again to explore different parts of the moon's surface. They're landing in 2 different areas. But the idea is to build up our understanding, of course, related to the Artemis project.
Right. Trying to get back into being able to go to and land on the moon safely.
Now, one of these spacecraft is developed by Firefly Aerospace. So it's known as the Blue Ghost Mission 1 lander.
Okay.
That's the one you see on the left, and NASA's partnered with that, which is why you see the emblem for NASA on there as well. And on the right is actually a Japanese lander, and with it is a rover. Now, this is mission number 2. The first one failed. So this is the second try, but of course, they made it better in the sense that they've improved the technology. So the lander is known as Resilience. It's a good name for it, since the first one went down.
Okay.
And the rover itself is Tenacious, which is I like
Sorry.
the naming.
I like the names, but yeah, my mind went to some pop culture references.
Okay.
So.
And iSpace Incorporated is the company that designed the lander and the rover.
Nice.
And those will be launched. Now, they're on very long paths or routes to get to the moon. So, first of all, the one from Firefly is the one on the far left. So, that will go into orbit around the Earth and stay there for quite a while. It's not like going directly off to the moon or anything like that. So, it'll take several weeks for it to eventually attempt to land on the surface of the moon.
Okay.
And the second one, which is displayed on the right, that actually has the one from iSpace, that actually takes a longer period of time to eventually try to land on the moon itself. It's going to go in an orbit around the moon and stay there for quite a bit. And of course, they're going to check out all the equipment and make sure everything works perfectly, or at least anything that would involve what they need to land on the moon itself.
Right.
And so we'll see how this plays out. But it's sort of in that chain of going down the different things that we need to open up the exploration of the moon itself. Now,
Right.
but this begs the question of how things would change with the change in administration, which is less than a week away.
Right.
So NASA's going to have a new administrator.
Mm-hmm.
So this person needs to be confirmed yet. It's the rich person that's part of the private flights using SpaceX, not Elon Musk. It's Jared Isaacman. And he knows a lot about space. He's an aviator. He's been in space recently. He did the spacewalk, first private person to do a spacewalk.
Okay.
And so he's got a lot of experience in rockets and dealing with astronauts and the training they go through and all that kind of stuff. So that's not unusual. We've had other NASA administrators in the past that have been in space. Mm-hmm. And the current one was on board the space shuttle on a flight. So he's been in space. So there's nothing new there. But what's new is that if you want to think about the grapevine, what's coming down the rumors, is that there is a 5-person panel that has been assembled already that has been exploring what to do with the Artemis project. Now, the Artemis project, that is going back to the moon, relies on the Space Launch System, the SLS. That's like a glorified, in some sense, Saturn V. Mm-hmm. It uses a lot of the shuttle technology, like extended longer, in other words, solid rocket boosters on each side of an external tank, like the space shuttle. And it uses space shuttle-like engines. Instead of 3, there are 4 of them.
Okay. So you can get enough thrust, enough specific impulse.
So it's like taking the technology from the Saturn V and merging it with the current technology coming out of the shuttle program to try to come up with something better.
Right.
And that makes sense, right?
That makes sense.
You advance your technology and what you've done in the past. You're not going to reinvent the Saturn V exactly the way it was.
Right. And the
things.
space shuttle at the same time did not have anywhere near the thrust, the power to get to the moon. It was doing good to get in the low Earth orbit.
Yeah, only low Earth orbit.
Only low Earth orbit.
To get to a higher orbit, they would attach an additional solid rocket booster on your spacecraft, like the Chandra X-ray Observatory had to be boosted into a higher orbit. The shuttle couldn't reach the high orbits.
Right.
Which means when those things break down, people might think, well, just send up the shuttle to go fix it, like the Hubble Space Telescope. The shuttle can't reach those high orbits.
Right.
And there were talk, to change that. I mean, there was talk of putting extra rocket fuel and oxidizer in the cargo bay and feed it to the orbital maneuvering system as a sort of an extra tank. And that'll allow it to reach those higher orbits. But that never ever happened.
Never happened.
I think someone did the cost-benefit analysis on that and said it probably is not worth it, right? Strap on a solid rocket booster stage and let it go that way, but we just won't be able to get up to it.
Right.
Anyways, so what they're looking at, I guess, this panel is whether to just dump the SLS, get rid of the program from that point of view altogether. And the reason for it is that each rocket launch, and there's only been one so far, but unmanned.
Right.
Each rocket launch costs, and depending on who you talk to, several $1 billion. So it is not
That's not economical.
cost effective.
Yeah.
That's the problem. Especially when we have other things that can do the job, probably. Things that are being designed currently by SpaceX, including Starship and Blue Origin now.
Yeah.
And that would be the New Glenn rocket that was supposed to be launched a couple days ago. It's been pushed off to the end of this week now, I understand. I think Friday evening, Saturday morning.
Something like that.
But we'll see. That could be delayed further. It's better to get things right than launch and blow the whole thing up, right?
Right.
You want to make sure everything as best as possible is ready to go. So private companies are developing the technology so that it's much cheaper to send up payload into space, including going to the moon, rather than relying on NASA to do it through the SLS. And as part of that was when the SLS was designed, people call it the Senate launch system because it seemed like the senators were pushing for that project. They weren't killing it.
Right.
This was before the Artemis project was fully developed as a job sort of thing in their state, right? Let's keep the jobs going by having them to develop and build this rocket.
Yeah. I mean, let's face it. The space shuttle type engines are still being built at Michoud because the Louisiana senator pushed to keep using that, so the Michoud plant would stay open.
Well, that's where the external tank is built.
And right.
In Louisiana.
I know that because I'm from the area. So.
Yeah. So the external tank is built there, and then it's test fired on the test stands are in Mississippi.
Yes.
To test
Stennis
those
Space
engines.
Center.
Yeah.
Yeah.
So all of the, I mean, it's all jobs.
It's all jobs, and it's all hand washing. You know, you wash my hands, I wash yours.
NASA was smart in some sense. When NASA was set up, they didn't all put everything in, let's say in Florida, where the launch site would be.
Right.
They spread it out. And there's a lot of politics involved. For example, the mission control is in Houston. Why do you need it in Houston? Why don't you have it in Florida where the launch takes place? Right? It's a political decision. And that's why a lot of the NASA centers are spread around the United States, you see, to spread out the votes.
Yes.
And so one of the things that coming out of this proposal is to actually fold up the Ames Research Center and the Goddard Space Flight Center and put it all into Marshall in Alabama. So,
interesting.
So they're going to, if you like, consolidate some of the NASA centers.
Okay.
As a cost-cutting, more efficient type of thing to do. That's the ideal anyways. But getting rid of the SLS, I mean, SLS was due, it's due now and to send up astronauts around the moon and then come back.
Right.
And now in 2026, it's been delayed, it seems
a year,
like all the time.
Year and a half, something like that.
Every year it's delayed 6 months or something, right?
Yep.
So the idea would be you get rid of that rocket. And well, the goal would be on the next flight, flight number 3, you'd be in a situation where now you can land astronauts near the south pole of the moon. But the lander hasn't been built
yet. Yes.
So you can't land anybody without a lander that's human rated.
Right.
And there are two major companies that are designing it, SpaceX
and Blue Origin.
And Blue Origin.
Yep.
And they haven't developed anything. And part of the SpaceX proposal was to use the Starship that they're developing, right? That they launch once in a while, which is coming up soon again. In Texas, right? In St. Padres Island area.
Mm-hmm.
Now, the problem is that's not developed to the point where you even can put people on it, right? It still has a lot of work to go.
Right.
So if you're waiting for the lander to develop, when do you launch with astronauts to the moon? In the 2030s? Because it's sure looking like that.
Right. And it is. It's looking like that. And by the way, yes, Extrabulla, I was making reference to the Stennis Space Center. Extrabulla is hometown.
Yeah. So the external tank is a Michoud. It's where they manufacture it. And then you have the test stand in Stennis.
Yes.
And so the proposal now is to get rid of the SLS as a cost-cutting thing, probably help SpaceX and Blue Origin develop the rocket technology more. And by then the lander will be built and then go to the moon, maybe a lot cheaper than what the SLS can do. And it was always in the back of people's mind that, we can get back to the moon, but we're not going to go there very often because this rocket costs too much.
Right. And the SpaceX, the Starship and Blue Origin's Glenn are more cost effective than the SLS. So,
I mean, why do you see so much stuff going up on the Falcon rockets now, right?
There you
I
go.
don't mean just the Starlink stuff, which is its own companies.
Right.
But I'm like tonight, the lunar landers are being launched on the Falcon 9.
Right.
Why aren't they being launched on a European rocket? Because it's too much.
Because it costs too much.
It costs too much per pound to send up that mass into space.
Right.
So you're
Whereas-
going with the cheaper, more, and hopefully a reliable rocket. But certainly, if everything is reliable, all things being the same, go with the one that's cheaper.
That's
obviously.
cheaper, obviously.
And
Yeah.
this stuff is expensive to begin with, so you don't want to waste money. In
There
that
you go.
sense. And it's mostly taxpayer money. I know private companies have their thing, but a lot of times a lot of development is financed through the government.
Right. By grants.
By grants and proposals that they're
Proposals.
looking to do certain things. Even SpaceX received a lot of federal money. It wasn't all Elon Musk's dollars.
Right.
So
It wouldn't have happened if it had not. Elon can say what he wants, but he wouldn't have done it if it had just been his money.
well, he
Sorry.
always said that he only had enough money for 3 Falcon launches, and the first 2 failed, and the last one succeeded. So he was ready to give it up. Now, whether or not that's true or not, I don't know. I can't read the guy's mind, right?
Right.
But this stuff is known for failures. The rocket stuff, right?
Rockets
It
are
needs-
hard.
Yeah, that technology needs to be developed to a certain point before it becomes reliable enough that you can make money from it. Imagine
But
that
he's done that. He has managed
yeah.
that.
You imagine that your rockets fail at a rate of 50%. So every 2 rockets you launch, one of them statistically blows up on the launch pad, let's say. How are you
Right.
going to make money for customers? Nobody's going to trust you to launch their $100 million satellite plus on
Right.
your rocket if you got a 50-50 chance of making it.
Fortunately, he's doing much better than that.
Yeah, and that's it. You have to improve that technology, right? And he benefited from NASA because a lot of the NASA engineers, rocket engineers, migrated over to SpaceX when the shuttle program was winding down.
Right.
And so it wasn't like you had to start from scratch to find those experts. They were there.
Waiting to be picked up.
And so that
Yeah.
helps.
So, yeah.
Now, the other thing that I wanted to talk about today, so this involves Mars. Now, look at this on Mars. Someone's got a campfire on Mars, Robert. What do you think they're doing there?
They're sending smoke signals trying to communicate that they're being invaded.
With the Martians?
Yeah. They're trying to communicate and say, hey, we're being invaded by this strange stuff.
Now, when we talk about the moon like we've done, the moon essentially has no atmosphere. It's a tenuous layer of some sodium atoms and some other things, but essentially it's almost a perfect vacuum.
Yep. Basically a very thin layer of very tenuous, volatile elements.
Yeah, that get outgassed from the surface and so on, right? And then cosmic rays impact the surface of the moon
And sputter off
and
more.
sputter off material. But Mars itself
Yes.
has an atmosphere, and people sometimes forget that
Right.
because of our connection with thinking about the moon. In fact, what you see in this image, which is kind of cool, is an image taken of dust devil. So there are dust devils
So there's even thermal gradients within the atmosphere.
Yeah, and there's clouds in the sky, right? The
Right.
rovers and the landers have tilted their camera and pointed upward in the sky and took images of clouds, and people even study the cloud features, the structure.
Now, those clouds are CO2, if I remember, CO2 ice crystals. They're not water vapor or something like that like we have here on Earth.
Yeah, so it'd be interesting to study those clouds and compare them what we see here on Earth and those kind of things. I'm sure you get
Now-
a lot of information that way.
Okay, it tells us in the credit. Yeah, I figured this had to be an MRO
Yeah.
image because it's too high resolution.
Yeah, Mars Reconnaissance Observer. That's been up there, orbiter.
Orbiter.
Sorry. That's been up there quite a while now.
It has.
I think over 10 years for
It's
sure.
definitely
that's been
over
up.
10 years.
Yeah. So there are dust devils on Mars. Now, the beauty of it, when you think about landers, is that there's a lot of dust on Mars. You know, Mars is famous for periodically dust storms,
Right. Global dust storms.
global dust storms. So there are dust that gets deposited on the surface of everything. In fact, in the last podcast, we talked about one of the landers that are being covered with dust. But a lot of these landers had solar panels.
Yep.
And what happens over time, of course, is,
You get covered with dust and they're not as efficient.
and then out comes Robert with his broom.
I wish.
Okay, vacuum cleaner?
No.
Now, why don't they have their own personal vacuum cleaners?
That's a good question. I mean, I understand why they don't have like windshield wipers, which has been suggested because those bring their own set of problems and get clogged up by dust and everything. So I get that, but why not a vacuum cleaner?
You know, the can air that we use to clean the inside of a computer with?
Right.
Why can't we have some bottles of can air situated at the right angle that we can let that gas go, brief pulses, to clean off the surface of
We
the
need to
solar
work
panel?
for NASA because I was thinking also we could have the solar panels where they'll
tip up?
tilt and then vibrate, shake.
Yeah, and then use the air pressure to blow off the remaining dust.
Right.
So over time, the dust accumulates on the surface of the solar panels. That causes, of course, the power output to decrease. In fact, we've had lots of situations where it decreased to the point where the electronics stop working because they freeze and they crack, and that's the end. Your circuit is broken. And so we've had a lot of landers, even rovers, that have run into this issue already. And what happens, interestingly, if you're not aware of this, is occasionally, and depending on where you are on Mars, that a dust devil will go by. It will sweep by your location and blow off that dust, just serendipitously, off the solar panels. And all of a sudden, whoop,
all your power
comes back. And you're like, oh, right, now it's warm, this kind of thing. And so people have looked at the tracks of these dust devils. And here is an image of some area, one section of Mars. And each of that black pattern that you see here is a path of a dust devil.
This is obviously an enhanced image so that it gets the contrast to bring these out.
Yeah, so the dust devil steers up the dust on the surface to the point where the contrast, you can see it, right? Yeah. Where the path of it has gone.
Now, this is both a benefit and a problem because the dust that settles comes from these dust devils as well, because it's blown up into the atmosphere and then eventually settles out. But at the same time, it clears it out.
And if you look at the patterns, they're actually kind of cool. Look at all the twists and turns and the swirly pattern that it's making. And of course, what determines the trajectory of a dust devil?
It's the thermal temperature gradients in the atmosphere.
So you can use this to backtrack that information.
Oh, you can. Oh, that is cool. Sorry, I'm having a geek moment here for a second. Wow. That is, yeah. It's like I noticed looking out the window one winter my office had a window that looked out onto the side of the building, and I noticed the way the snow was swirling again was like, hey, you can use it to map the thermals around the building.
Yeah.
And this is the same type of idea.
Yeah, exactly. So that's a lot of useful information I'm sure you can get from studying these type of patterns and how they evolve with time.
Yeah.
So it's kind of interesting. So I thought this was a real cool image to show.
Yeah.
And it really, gives you the impression, boy, there's some areas of Mars have a lot of dust devils.
Indeed.
And that's why during a 5 or 10 year mission, if you're waiting for something to clear off that dust, if you're in the right spot, the chances are it's pretty high that it's going to happen. Yeah. Now, it's my understanding as you get towards the poles, the frequency of dust devils goes down.
Yeah.
And so we've had problems where landers have had or accumulated enough dust that they eventually died, but they were like kind of pretty far away from the equatorial regions.
Right.
So
you got to remember, dust devils are a thermal condition, so you've got to have enough heat energy from the sun to even get them to form. So when you get off the equatorial bands, there's just not enough ambient energy being deposited to lead to the thermals.
Now, I've seen one dust devil in my life that was really large and well-defined.
Oh, wow.
Because where I grew up, we really didn't see those swirls and stuff, but this was like a stovepipe type of dust devil. It was the middle of the afternoon. I was sitting in the airport in Tucson, Arizona, waiting for my flight back home after I just spent like a week observing at Kitt Peak National Observatory. And everybody was looking out the window, so I glanced to see what it was, and there was this well-defined dust devil off of one side of the runway.
Wow.
It was amazing.
We used to play in them on the playground. We used to play in them. So.
See, we never had ones that would be that consistent and last longer where I grew up, right? They just didn't happen.
I wouldn't have thought of that, but yeah, you grew up in Canada, and I'm from the Gulf Coast
region.
So
Nova Scotia, and we don't have tornadoes, right?
Right.
The conditions are never right to support the formation and for a tornado.
See, you get the same type of effect happening here on Earth.
Yeah, but it was pretty cool to watch it. I said, it was a really well-deformed, curved pipe, almost like a stovepipe tornado type of thing. Now, of course, a lot smaller in size.
Interestingly enough, do you know where I've seen most of the dust devils, although they weren't dust in this case?
Water
Over the Gulf of Mexico itself.
Like water spouts.
Yeah.
Yeah.
So, great stuff,
Yeah, it'd be nice to be able to. Could you walk into it without being hurt?
A water spout? A forming
Or
one,
a
yes.
dust devil.
Or a dust devil, yeah, dust devil's no problem.
Yeah.
You can walk into those all day long.
Just put your goggles on so you don't get blasted in the face with the dust.
Yep.
And your mask, your COVID mask.
Yeah, I mean, they're tornadic, but they're not tornadoes.
They're not going to throw you like
They're not
300
going to
feet.
pick you up and throw you around.
Right.
Yeah. Now the water spouts can.
Right.
So-
well, aren't they really tornadoes over the water?
If they come down, yes. If they start at the surface of the water and go up, no.
Yeah, I was at the Daytona Beach one time, a long time ago, and I was talking to a guy from that area, and I was asking, do you see any tornadoes around here? He goes, yeah, I see water spouts all the time,
Right.
and occasionally they will come in and land, right? But most of them don't.
Most of them
They
don't.
stay out.
Right.
But he said, yeah, you can see them quite frequently in that area. So.
It's
Now-
good stuff.
Speaking about Mars,
Okay.
the other thing I noticed is a paper that was published recently, and this paper talks about the fact that if you're looking for life on the surface of Mars, you have to be very careful. There are deposits, volcanic ash, that covers up the soil in certain areas to the extent where signatures that would indicate the potential probability or potential of life arriving on the surface. And you could think of microbial type life is what I'm thinking here. So I'm not thinking about life prints. I was going to say, you can't say human prints, right? Or footprints, because they might not have a foot. So what would you have, like a tail prints if it was like a dinosaur with no feet? I don't know, whatever life form you can imagine.
yeah.
Right? It would have some type of depression in the soil, right, from its weight. But this would cover up some of those sort of features that we would look for, right, when we're doing remote sensing of different parts of the soil of Mars,
Right.
looking for evidence potentially of life. So remember the finding of phosphine and the big brouhaha over its existence in
And
the
the
atmosphere of
methane
Venus.
release and all of these
So
things.
phosphine would be something that life would produce, biological life, biological activity, and yet it can also be produced from non-biology.
Not
So is it-
abiotically.
so yeah. So where does it come from, right?
Right.
And you can't tell, of course. From
And the same thing is true with methane. It was found there was a bloom, a big release of methane on Mars, and people are like, "Oh, an indicator of not life," except there are abiotic processes that can produce methane as well.
right. So this particular area on Mars is important because it's where the ExoMars rover is going to go when it gets
Okay.
launched in a couple of years. So its launch is slated for 3 years from now. There's a little bit of history with this rover. It's from the Europeans, European Space Agency. It was a rover that was due to be launched in collaboration with Russia just prior to its invasion, or
Of
whatever you want
Ukraine.
to call it, of Ukraine.
Right.
And when that occurred, of course, the cooperation was cut off and the rover wasn't launched.
Okay.
So the European Space Agency have redesigned the mission so that they can launch then without Russia's involvement.
Okay.
And they're going to land in this particular area. So it's known as the ExoMars Expedition and the Rosalind Franklin rover. And you can see an artist's drawing of it there in the bottom right. And in the top right is the area of Mars where it plans to
And so they're
land.
going to land on one of these tephra fields.
Yes, exactly. And the idea is, how do you get away from that volcanic ash that can potentially hide signs of life? That may be an issue.
Right.
Because if it's enough of it there, even spinning the wheels, if you like, on the surface of Mars to try to go under a little bit, under the soil, the topsoil,
Right.
will you get below that layer that's hiding potential evidence of Martian life?
Yeah.
Think of Mount St. Helens, right? The volcano.
Right.
How much volcanic ash was deposited in the general area of that
Yes.
volcano? A lot.
A lot.
So how are you going to
Having
get?
been there, a lot.
How are you going to go underneath that to look for this guy?
You're really not.
You're really not. So you'd have to go away from that area to where the ash thins out.
And in fact, on the edge of that ash would be a good place to look.
Yeah, and then kick up that soil, if you like, with the wheels. I'm not sure if this has like an arm that can scoop up the material. There's nothing displayed in the artist's conception.
Right.
But the wheels can certainly turn up that stuff. We've had that happen in previous U.S. rovers on Mars.
I just hope the rover doesn't sink into the stuff. Tephra and ash deposits are not that firm.
Well, it's like talcum powder.
Mm-hmm.
One would think you'd take your rover and play in a sandbox of talcum powder-like material to see how well the wheel that you use, the design of that wheel, can survive in that type of
I hadn't
environment.
thought about that. Hopefully they will.
They do
Hopefully
that. I mean,
they've done that.
JPL is well known for that, right? They
Right.
do all that kind of work. And thankfully, JPL was spared so
Yes.
far in the
Yes,
forest
so
fires.
far. And so was Mount Wilson. So, hopefully that will continue.
There's a lot of space-related activities that occur in the Los Angeles area, and of course, people live there, and we really feel really bad for those people
Right.
that lost homes and so on, or their lives have been torn
yeah,
apart.
I mean, we don't want to say that we're more worried about that. People
Yeah.
have lost their lives, but
it can have an impact on a lot of
a
things.
lot of things.
Yeah, for sure. So the other thing that I wanted to bring up is this other study, and this is something, Robert, that maybe you can dive into a little bit more.
I actually looked up this one as well on my own, and basically what they're going on is there was a lot of volcanic activity going on within a few thousand years of the Chicxulub impactor. And so it's always been a consideration of, did the dinosaurs go extinct because of Chicxulub, or was it a contributing factor? Were these volcanic eruptions? One of the famous one is the Deccan Traps in India. And, were these things more to blame for the disappearance of the dinosaurs than the Chicxulub impactor? And from what I've seen of this investigation of that, looking at paleoclimate chemistry, because there are certain minerals that are in equilibrium with another mineral of the same composition, but they changed crystal structure and contaminants based on the temperature. So we can get a gauge on how warm or cool things were based on this chemistry. And so looking at that, the conclusion that I've seen was that no, while there was definitely some climactic effects of these large volcanic eruptions that produced the Deccan Traps and other such provinces, the impacts lasted for very brief times and they may have contributed to a reduction in populations, but they were not the cause of the extinction event.
Now, the asteroid that's earmarked to have wiped out the dinosaurs back roughly 66 million years ago. It used to be 65 million years ago. Did you notice that? Now
I've
everybody's
noticed that.
using-
Now they're saying 66.
So it must be closer to 66 million than 65 million or something.
I think they're probably doing some radiometric dating with the iridium and other things,
So it was in like the Chicxulub area of Mexico, right? The impact site.
which is right on the Yucatan Peninsula, right at the Gulf of Mexico, the shoreline.
And one of the evidence that it was an asteroid-like thing that wiped out the dinosaurs was discovery of the iridium layer back in
KT
at least
boundary layer.
back at least in the early 1980s, if I remember right.
Yes.
So if you had volcanoes that wiped out the dinosaurs, would you get that iridium layer?
You would not, because the iridium is what we call a siderophile element. It likes to be alloyed with iron. So all of the iridium, or most of the iridium that was on Earth, was drawn in when the core separated out from the rocky part of the Earth, the mantle. And so there's very little iridium in the crust and in the mantle. And as such, if you see a high concentration of iridium, that's an indicator that you had an impactor, because iridium is common in asteroids and meteors.
And we've sampled those.
And we have sampled those.
So we know directly how much iridium we expect in certain types of asteroids that we have sampled.
Exactly.
And also in meteorites that fall on the surface of the Earth.
So you've got this worldwide layer of high concentration, with a high concentration of iridium across the globe, everywhere. This layer turns up, and it turns up in about the same strata, the same layers of rocks. And those layers have been dated radiometrically and otherwise. So there was definitely a very large impactor.
So if you were living in China and there was no people around, back when it happened 66 million years ago.
Which
But
there wouldn't have been. But
Right. So if you were alive and let's say you went in a time machine, a DeLorean, and got it over 88 miles an hour,
Yeah.
and you go back 66 million years ago, just an hour before the impact, even though you're in China, essentially on the other side of the world from the impact site, the asteroid was massive enough that if you think about the raw energy that was released in the collision with the Earth, that it kicked up all of that material, including iridium, up into the Earth's upper atmosphere, and that circulated around the whole globe, and then gently came down and deposited all over the Earth.
That's exactly what happened. I mean, to put it the size of the impactor at Chicxulub, which we've now seen the crater for, to put it in perspective, it would have been, I think it's 7 miles long in size. When the front end of it contacted Earth's surface, the other side of it would have still been in space.
The back end of it.
Yeah, would have still been in space. That's how large this thing was. So it wasn't like the meteorites that fall, that we're familiar with, that fall, they hit and punch a crater. This thing would have taken a minute or more to actually collapse and complete its crash into Earth. And that's just, wow.
Do you know if there's been any type of magnetometer scans that have been done in that general area to look for large concentration of maybe iron that's in part of the impactor that's embedded deep inside of the Earth at that area?
Not that I know. Well, I mean, people have obviously looked, but they've drilled into the center of the crater now, and that's how they know it is. One of the reasons that they know beyond a doubt that it's crater, because you've got all this turned over material that should have been deep is now on the surface. Surface materials are now being found deep inside the center. I don't think there's any iron that's been found, because you got to remember all of that energy from the speed of the impactor plus its gradual impact is converted to from kinetic energy to potential energy to thermal energy. So in all probability, the solid impactor was probably vaporized. And in fact, that's where the layer of iridium came from, is it was vaporized, pumped back into the atmosphere, and fell down everywhere. Because, yes, there is a lot of iron in there. So Wondergoon is asking, did the Chicxulub impact alter the orbit of the Earth?
It had to.
It had to have. It absolutely had to have.
Not so dramatic as it would send us, of course it didn't happen, but imagine sending us spiraling outwards to the outer solar system or inwards towards the sun. But, in fact, the rotation of the Earth is altered when we have earthquakes.
Right. A way to think about this is to set a basketball on a court, then take a BB gun, stand about 30 yards away, and shoot the basketball with it. Does it make the basketball move? Yes. Does it really make it move? No.
Yeah. Is it significant, in other words? And it wasn't this. We don't expect it to be a significant
impactor.
And you can model, you can simulate that. So it's not something that you just guess.
And I imagine there's a paper out there where they did just that, what the effects were.
Yeah. The other thing is, that explains the extinction of the dinosaurs, as far as we can tell today. But there's been lots of mass extinctions in the past.
Right.
How many of them, do you wonder, has been tied into impactors as well?
There's one other I remember that they think was the product of an impactor. The great extinction, the great dying, at the end of the Cambrian has been been linked to methane clathrate release. And so the temperature of Earth went up radically over a very, very short time. And
you mean climate change?
Yeah, well, yeah, that's
natural climate.
That's one of the reasons why some of us, we talk about CO2, but if the ocean warms up enough, those clathrates melt and the methane is released, and holy crap, we're in for a wild ride at that point.
Yeah.
The great dying.
Yeah.
So anyway.
Because when you go back in time, there was a period in the early solar system called the early and late bombardment, where there's a lot more debris left over from the formation of our solar system, essentially, than there is around us today.
Right.
And a lot of that material impacted various bodies, got pushed into the sun, directed out, or got ejected out of the
Out
solar,
of the solar
system
system.
altogether. And that's where all the cratering, most of the cratering comes from when you look at the moon, when you look at Mercury,
Yep.
and all these other bodies. And every body that doesn't have a way of eroding its surface through ice flows or whatever, tectonic activity, is heavily cratered,
Is heavily cratered. Yeah.
right? I mean, unless you're like in a place where you have lots
And-
of wind and weathering like here on
And
Earth.
clearly that cratering couldn't have happened recently because, well, we wouldn't be here,
Yeah.
you know.
So you'd wonder how many impacts that like the Earth sustained, especially in its early history.
Right.
So you can imagine like conditions would arrive that maybe are conducive for the formation of life, and then bang, an impact happens, and those life forms get wiped out, and you got to wait hundreds of millions of years to go by. The life takes a hold, and then bang, another impact happens, right? So you go through these cycles. But the question I have is the last one was 65 million years ago. When's the next bang?
When's the next bang? It's a good question.
To recycle life again.
And, you know, we've got programs out there. We're spending precious little money on it, but there are programs where they're looking to identify all the Earth crossing objects.
You know, back in, this would have been the mid 1990s, I was at a talk given by a professional astronomer from Princeton. And he stated that the number of people at that time that were looking for dangerous asteroids was less than the number of people required to run a single store at McDonald's.
Right. And he's professionally he's correct. As you know, there's a couple of movies from the 90s that got that part right. While there's a few handful of professionals looking, there are hundreds of amateurs looking. So, I mean, we've got good amateur telescopes now. We've got cheap optics
Yes.
that you can go out and buy.
Especially compared to the mid 1990s, things have improved. And I think the United States government, and since that time, they come out with the idea is they want to detect a certain size asteroids down to
Right.
like 1 kilometer,
Right.
and to be able to detect like 90% of them.
I think they're looking for everything down to what I call city killers.
Yeah.
You know, because there's a certain limit. If the object is this size, it'll wipe out a city. If it's this size, it'll wipe out a continent, and so forth.
And one of the problems with it is you can map out the distribution of all of the bodies orbiting the sun.
Mm-hmm.
But then that distribution changes because there's different perturbations. I mean, even the heating effect, right? When the sun shines on one side of the asteroid as it's slowly making a rotation,
Right.
that is on what you're heating it up, and then infrared photons get released. Over time, that acts like a little tiny rocket thruster.
That's a thrust. Right.
So it changes the orbit of these objects, and they have very low mass compared to planet size. So it's a
Right.
lot. You don't need as much thrust to change significantly their orbits.
Right.
So, and one day there's nothing that's going to hurt us, and then 50 years later,
Oops.
yeah. So you got to be constantly
Looking.
on your tippy toes, you know, looking at things. And the other thing is, we have a huge collection, as far as we know, of objects way outside in the outer fringes of our solar system, where it's so cold, ice is hard as steel, right? That's
Right.
kind of stuff. And inbound objects from that region, from way out in the Oort cloud, could be on orbits. You know, this particular comet that went by the sun now, I thought it said something. What was its orbit? Did you catch the orbital
I didn't
period?
catch the orbital period.
It's like, I thought it said something like 160,000 years or something.
Sounds about
It's
right.
a huge number,
It's a
right?
huge number.
So it came from way outside in the Oort cloud, essentially. How many other comets that are way more massive than the object that wiped out the dinosaurs that's inbound now?
Right.
It's just going to take a long time maybe to get here. But maybe 100 years from now, 200 years from now, we spot one of these suckers in the inner solar system heading in our direction.
Yeah. Well, the thing is there we won't see it probably until it hits about the orbit of Jupiter when it starts outgassing. Gets hot, warm enough to outgas. Then all of a sudden, oh, here it is. By that time, since it came from so far away, it's picked up speed the whole way because it's falling into the sun. And so it's moving. We've got 3 months maybe.
Well, that's the problem. You want to be able to detect these things early enough so then you have years, if not decades, to organize some way of mitigating, the danger.
Yeah.
And there have been different things been proposed. For example, well, what better use of our nuclear weapons? Let's nuke the sucker.
Yeah, but we still got to assemble a rocket powerful enough to get it out to meet it.
And then with nuclear weapons hit it, if it's a real massive object, what do you think is going to happen with our nuclear weapons going off?
Well, it's going to ignore it. It's going to be like the Chicxulub impact on Earth. It's going to be, oh, something happened.
It'll be like a mosquito smacking you in the forehead when you're streaming down the road on your motorcycle.
Or even if it breaks up, if it still stays in a tight enough clump, which do you prefer to be shot by, a rifle or a shotgun?
Yeah, you break it up into pieces. So instead of one piece coming in, you have, hundreds of pieces coming in, each of them able to do major damage to the Earth.
Right.
One of the things I did propose, which is kind of interesting, is what you do is you park a spacecraft nearby the object.
Right. And
the mass of that spacecraft will pull that object towards it slowly. And if you can just get it to, shift in its orbit just a tiny bit, by the time that object comes from the outer solar system and reaches the Earth, it has moved enough in its orbit that it's missed the Earth altogether.
I mean, one of the proposals I've seen is to park like observatories around Jupiter, in orbit around like Jupiter, to look for these things, and then have another set that's orbiting inside the asteroid belt that will be mass tractors that can go out and intercept it.
Yeah, in fact, you'd want to have spacecraft already out there.
Out there.
Right, so you just got to use ion propulsion engines or something to try to match the orbit to fly up to it.
Yep.
To start following it for a long time period to be able to alter its orbit.
But again, this takes dedication, it takes will, and it takes money. Money in the way of it takes resources.
Now, it's interesting that the European Space Agency are developing, I believe it's 2 probes that are going to go into orbit around the sun.
Mm-hmm.
And they're going to be out there looking for things like Oumuamua.
Right.
You remember Oumuamua?
Yep. Interstellar traveler.
Yeah, so it was an asteroid that was on a hyperbolic orbit, which means it wasn't in orbit around our sun.
Right.
That came from interstellar space, and we don't know where it came from.
Mm-mm.
And it went through the orbit, or through the inner solar system, went around the sun and back out again. And we caught it, we observed it when it was on its way out. It already passed close to the sun. And it's going so fast that really, unless you spent a lot of money quickly and design a spacecraft to get to it, it'd take a lot of effort to get to it.
Right.
So the idea that the Europeans have, and others have suggested this, is if you have spacecraft already out there orbiting the sun,
they can intercept it.
They can intercept it a lot easier than trying to design things from scratch and get it out there or whatever, right?
Right.
So, I mean, people even propose what would it take to catch up with Oumuamua, went by many years ago now, right? And it would take like a tremendous amount of, you got way beyond the orbit of Pluto, if I remember right.
We have no rocket that would have been able to produce thrust and accelerations capable of reaching
have it very low mass so that you do put on existing rocket, and it would have to have the ability, like ion thrusters, to try to get out there as fast as possible. That takes time. So really, it's not worth the effort or the money.
Right.
Because the idea is maybe you're going to find other things that are inbound from some other star system. And we have a very large telescope, a Vera Rubin observatory that's taking its first images now. In fact, one was released today at the Super Bowl of Astronomy in Maryland. And this showed a nice field of view with the center region has a nice image. So they haven't used the full camera yet. And so they're ready. That telescope will soon be in operation. I believe it's later on this year.
So maybe not next week, but the week after we could have that image.
Right. That's part of one of these updates that we talked about.
Yeah.
And the thing is that this telescope, which is an 8-meter class telescope, is going to survey the whole southern sky approximately every 3 nights.
Nice.
And that's a huge area. That's
that'll spot things moving.
Like over 20,000 square degrees, if you know what that is, right?
Yeah.
So think of the moon, right? And there you can get 4 moons, full moons, if you look at it, in 1 square degree, and there's still a little bit of space left over. So you're talking about 20,000 square degrees.
That's wow.
At least that,
Yeah.
The full sky is like somewhere on the order of 48,000 square degrees, right? So you see roughly half of it in one location. So that one of the things you're going to look for is these type of objects, you see. So we'll be able to better monitor the sky, at least in the south,
Right.
for these type of things to see if there's anything on its
See if
way
they're coming in.
that we have to worry about.
Right.
Now,
Absolutely.
if you want to learn more about the things that we talk about on this podcast, if you want to learn more about physics, science, any STEM field, or maybe non-STEM fields, please consider coming to the University of North Dakota. We have a lot of programs, both online and on campus.
Have great faculty.
And if you're here, don't forget to visit Robert and I.
Visit us.
We love
We
to
love
have
visitors.
a chat with you for sure. Now, our next podcast will take place a week from today. So that'd be on January the 21st. So almost at the end of January already. You believe that?
I can't believe that.
That's flying, I tell you. Now, at the end of every podcast, we always leave you with a quote. So today's quote is by Eugene Parker, which the Parker Solar Probe was named after.
Yep.
And Eugene Parker, who died in 2022, not that long ago, he is famous for coming up basically with the first real good scientific model to explain the solar wind
Okay.
that comes off of the sun, and he did other things as well. But the probe, and he was around to watch the probe. He was at the launch of the spacecraft in 2018.
Nice.
So he passed away like 4 years later.
I'm glad he was able to do that because he was a story of vindication.
For sure.
Because he was laughed at for the idea that particles could leave the sun.
Yes, exactly, and it turned out to be the truth.
The truth.
So here's a quote from him. The solar probe is going to a region of space that has never been explored before. It's very exciting that we'll finally get a look. One would like to have some more detailed measurements of what's going on in the solar wind. I'm sure that there will be some surprises. There always are.
There always are. Always are.
Thank you very much for listening. If you like, please give us a thumb up and subscribe to our podcast. If not, we'll see you next time.
We'll see you next time. Have a good day, folks.